Hello and welcome back to Evening Rust. This is the first day after the competition and we have to do something new today. I just finished replacing the light. I know it still flickers, but it was flickering a lot worse and I really don't know what's up with the camera. I mean, do you guys actually see that continuous flickering of light or is it just my display here? I don't know how to fix that, but okay. It's weird. The lights don't flicker. They're all LED lights, so it shouldn't happen. Nevertheless, moving on. The competition did really well. We got to... Where is this now? Somewhere here. Somewhere here. The Bottoms of the Galaxy is what we finished on Sunday. And once we made it to Legendary, we made one tweak and submitted it and just went with it. And that got us up to 68th. I'm very happy with that. It's in Legendary at 68th out of 1700. We were up to 30 for a while, but people kept modifying their bots and it pushed us down a bit and then they reevaluated. In terms of language, though, we did quite well. Of course, there's not so many people playing with Rust, but with Rust we came in second, which looks wonderful to come in second, even if there's not that many people that used it. But that was wonderful for us. We did great. I'm writing up a post-mortem for this, so I'll come the code. I have it almost done, but I went over the strategy stuff, and I'll post the post-mortem as I get it. There's going to be 2 or 3 parts to it, just so it's not too long to read at once. And then we have to move on from here. It was a lovely competition. I will do it again whenever we have the next one. But now we're going to go back to the normal compete stuff. Back to our old tradition. Let's join into a Clash of Code and see how we're doing. While we're waiting, we're going to go open up the Evening Rusts. GitHub. See something wonderful here. And go back to this. Is all the stuff we used during the game. We did actually use it. I should move the list around. We used all of them. And we'll set up a new one today. For the Clash of the Code, if you're new to the show, Clash of Codes are just short little things. Either we have to solve something quickly, or we have to reverse engineer, or we have to do golf. The quick stuff is an issue if it comes to the string, because Rust string handling isn't so great for doing things quickly in particular, or doing some things at all. Code golf is obviously a problem, but a lot of people have just issues with it, so we tend to do alright. And it's just a way to end the show, just break my habit from whatever I was doing for the day and see what's happening. I don't really care how I perform on here. Oh yeah, the competition put us quite high up in the ranking, so now we can be comfortably in the master level, so I'm a master. You see we jumped up because we were at master and I kept falling down here with little points, but this should give us enough realm here. And if we solve another multiplayer one, it should put us back up. And someday I'll go back and fix the Tron one. And that'll put us back up. That'll be good. So the next goal, of course, is to, as I said, the next goal, of course, is to become a Grandmaster and to break the 1,000 mark. That's probably the same thing. I'm guessing that's where they break it. You break 1,000, you become a Grandmaster. And so it's good. We were going for 2,000 before, and we made that. Now we're 1,000. Just waiting for a few more people to play. A bunch of people don't recognize. I think most people might just get tired of playing Clash of Code. I think it's mainly newer people. And here we go. Let's see what happens. Oh, I'm in a slow mood. Hopefully not speed. Hopefully golf. I think I'm going to lose. I can't think quickly right now. Reverse mode. Okay, 4. Oh, that seems reasonable. What's the output? Okay, this is the input, that's the output. That seems okay. Let's just do it like this. For I in n 1 dot dot n plus 1. Or 1 dot dot n, I guess. For j in 1 dot dot n plus 1. Oh, I'm getting confused here. So for p in 1 dot dot I, we're going to print plus, and that'll be 0 the first time. And then for p into n plus 1, we're going to print p minus, it should be I, sorry, p minus I guess. P minus I plus 1. And then we have to do a print line. Did I get this right? Without errors? Of course we have errors. Print line. Oh, yeah, I don't need that. Did you mean I? Where is this? Cannot find value. Yeah, J. So I meant J. Found nothing. Found nothing. Okay, I didn't go far enough. N plus 1. I should have put 0 to N. That's what I meant. Now we're good. So that was a relatively easy one. I like to start that way. We can share my code on that. And the backwards compatibility, I've had mixed luck on these things. Some of them I just don't understand at all. Other ones I knew what to do but couldn't get it done right well. Other times just screwed it up a lot. So it should be okay. That gives us a good speed there. I don't know why I did 1 to N on the first thing. 1 to N plus 1 should just been 0 to N for the outer loop. And that would have simplified it, but that's okay. Once you get thinking on the speed one, just go with it. And we'll see where we are. We'll just leave this. We won't do another one. And was this one fun? Sure, it was fun. Difficulty? This was relatively easy. Test case relevancy? I never know. I don't know. I mean, did our code cover all the cases? We never had an error, so I just can't say. Right, should be good. We'll see what other people... Hey, Omar! Welcome back to the show. We just did the quick clash of the code. That'll bump our score back up a bit there. And now we're going to go off and compete in something. There is a new game. We might as well do it. Even though, and I'll quickly say why it may be a bad idea. We're going to go off and do tic-tac-toe. Ultimate tic-tac-toe. This is no just normal tic-tac-toe. This is the ultimate. And this is a very interesting game, even to play it like... play on your own. And what are all the markers? So one was lost. Oh, those are just random cells. The game is, I can read the instructions later, but basically it's like classic tic-tac-toe, but in each little square you have another tic-tac-toe game. And no mean max for now. Did we do mean max already? I don't even remember. What was mean max? We're in the Silver League there. I don't even remember doing this. Oh yeah, we're at the, So we're at Silver League there. I have no idea how we got there. I barely remember programming this, and our guys did horribly. And we'd have to basically completely rewrite stuff to get further, so no mean max more today. I called the show Tic-Tac-Toe. I wanted something simple, although it's not going to be simple. So you notice here that they talk about Introduction to Monte Carlo Tree Search. This may be our downfall because Rust is being compiled in debug mode on their server. Daza, yeah, I'm still going to be using Rust. It's still going to be Rust the whole way until we get sick of it or know every little nook and cranny of the language. I'm just going to keep using Rust. That is kind of the purpose of the show, so... playing the games is an added bonus to see where we go, to get glory that way. But we're going to structure it based on the feedback I had from the competition about structuring things. We're going to have to we're going to have to find that Rust sweet spot. The community from Rust has been helpful, but there's no clear answer to the problems we've been hitting. And so now we're going to look for the answers. I mean, other than putting an RC ref cell and everything, and that's kind of ugly, but this game looks more in tune to what we need because there's a lot less branching state, there's a lot less structure in tic-tac-toe. It's a very simple sort of structure. This is a league-based challenge. Well, of course it is. Okay. So the first one, they said, we're going to start in the basic game, and we'll take our time to set this up because we have to have the basic game basically perfect. And we won't even do the Monte Carlo on the first one. We can actually do an exhaustive tree search, and it's a good way to start. And I'm really hoping that Rust is going to be fast enough on their server to do an exhaustive tree search for the initial game. If it's not... Do I look... Oh, sorry. I'm back in competition mode, just like nervous about everything. But okay, I'll relax. So, we're going to have to hope that we can do an exhaustive tree search of the basic game. If we cannot do an exhaustive tree search of the basic game, we might give up early, because that means our chance of doing the full game is going to be like basically 0. We have to be able to do an exhaustive tree search. And what is that going to be? To give you an idea of how many iterations that is, ignoring some certain optimizations. So you basically have 9 factorial. Daza, my life coach. Okay. Now I'm calm. Now we'll speak calmly. Now I want water. So, okay, Octave doesn't have 9 factorial. So let's figure out what 9 factorial is. Yeah, that feels much better. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So this number here, when you start a tic-tac-toe game, this is the number of possible ways it could play out. It's 362,880 ways to play out. And Daza, other than, I've been totally great since the competition. I mean, I've been doing Leaf programming. I have stuff working in Leaf. It's wonderful. I've got a Leaf on the screen, but now in GL accelerated mode. I was hoping maybe to do a stream tomorrow, but then some guy booked a mentoring session right in my stream time, but we'll find out when I do that. Okay, so in tic-tac-toe, if you ignore sort of any mirroring or similarities, there are 362,000 ways apparently it can play out, because I can choose one of 9 spots, they can choose one of 8 spots, choose one of 7. This isn't entirely correct, because somewhere by the 5th move, so by down here, you can already get to the point where some of the games have already won or lost. So as short as 15. Yeah, there's, oh yeah, factorial. Let's see if it's actually factorial 9. Yeah, that makes sense. So we probably, the exhaustive search, this is the upper bound of it, but some games end after some trees after 15,000 branches. Some of those branches already end, so we're cutting this out. I don't know what the exact number is. You'd have to prune the board, because once there's 3 X's on, the game is over. You don't keep searching for it. But what we're going to have to hope is that we can, in the basic game, iterate every single one of these branches. We're going to use the Monte Carlo counting technique and valuing technique, but we're not actually going to do any pruning or any part of the Monte Carlo simulation part of it. And this is sort of a good test ground, because if we can't do this for the basic game, we're not going to stand a chance for the full game and the number of iterations we can do, because we don't want to hit the complex game and figure out, hey, I can only do 1,000 iterations. What's happened? Oh, what don't you follow, Daza? Are you trying to figure out the numbers, or are you trying to look at the weird... Are you looking at the tic-tac-toe game? Yeah, I can explain it. The basic game here is tic-tac-toe, but when you play this game, what's interesting is that as you win a region, you actually get to put your X there, right? So whoever wins that one little game puts their big marker there. But there's an additional argument, is that when you play on the mini board, whichever region you play in the mini board, the next player has to play that spot on the big board. And if that spot's taken, then they go somewhere else. It's kind of an interesting game, and I don't know if it's actually been solved or not. It has enough depth to it that makes it a decent challenge. So we're going to start this out, and we have a 3. I'm going to assume it works. You can create your own game using the coding game SOK. So input for one game turn. 2 space for energies, opponent row and opponent column, the opponent's last action, -1 for the first turn. The number of valid actions for this turn. Why would it even give us that? That's weird. Why on earth does it give us that? We don't have to calculate what the valid actions are? Alright, well, we're going to have to calculate this anyway, so we're basically just going to read the first line and skip the rest, consume it. But now we have to set up the code first. It takes a little bit to set up first, so we're going to go over to my What is it? Cargo new bin. I forgot what this is. Cargo bin new. Tic-tac-toe. Ah, we didn't copy the .git again. Oh well. I told it one time to stop generating a Git, and it never does anymore. But we'll just copy our own anyways. It has more stuff in it. No, it doesn't. Oh, ignore that. Okay, ls source, and we got to set up the structure exactly as we did the last one, because that's how the creating system works. Daza, I'm using Linux, so I'm using Kubuntu 16.04, and we have to make a bin directory, make dir source.bin, and that's where the main's going to be. Coincidences. You guys are on the same wavelength. I'm taking you're not on an Ubuntu operating system. That you didn't recognize the layouts. So yeah, this is the Kubuntu layout. I like the basic way Kubuntu works. I like the Ubuntu system, but I don't like the standard desktop, so I throw KDE on it. There are some issues with it, but I think it works great. And it doesn't change every release. It's great. Every update, it basically stays exactly the same, which is what I want. I just want my icons here, and nothing changes. Okay. So make a bin directory, and I think we're going to have test directories. Let's just open up the old one first. I'm just copying a lot of stuff. Botters had this cargo toml, and we're going to copy bits of this to our new toml file. Hi3. Oh. So Eulers just saw you have one of those, let's say, alternative window managers. I like wiggly windows though. I can't give up my wiggly window. These expensive graphic cards exist only to make wiggly windows. Where's tic-tac-toe? Okay, so tic-tac-toe, we're basically going to take this bundle bits and just copy all of this over. What this does is bundle is the one that's going to pack all our files together so we can ship it off to Coding Game. Okay, we're going to open up the external editor on Daza? No, I use just Linux. I've been using Linux as my primary system for a long time. I don't even remember now. I don't have Windows anywhere. I have Windows at all. Once I stopped doing music, I didn't have a reason to keep using Windows, so I don't use it anymore. When I do music again, I'm probably going to get Windows because all the good software is on Windows. And well, there is, depending on the type of music you're doing, if you're doing a lot of electronic music, Linux works just fine, but for analog stuff like guitars and vocals, it wasn't a great option. I mean, it may have gotten better, but I haven't used it in a while. Select a file to start. Where am I? Yeah, I mean, it's a big preference which systems you use. Ever since Steam started supporting the Linux box and the Steam project, there's been a lot of games too for games, but obviously some games don't work there. But I usually use PlayStation for games, so I don't use my computer for games. I like the PlayStation because I got so sick of just trying to get the compatibility right in games. Hey, Moderated Seal, we're playing tic-tac-toe today. Where am I? Here I am. I'm going to go to tic-tac-toe, source, bin, put the main over here. Yeah, it does. I use a PS4 when I play. I don't play very often. I have a modest collection. And hi, Galva. See you again. Download the file. No, Omar. Actually, I do. Omar, I used to game a lot more, but I'm very picky with my games. If the game isn't awesome, I tend to quit playing, and so there's not very many, and I get bored of games quickly. I must say I like Dark Souls the most, so basically whenever a new Dark Souls, or sorry, whenever the new From Software game comes out, I will play that till the end. And, or if there's a new Fallout, that's about it. Fortnite, I don't know. Moderated Seal, no, it's not min-max, it's going to be Monte Carlo searching. Factorio, what is Factorio? Is that the one where you have little programmable robots? I'm playing robot games now. Technically, this is gaming, right? I mean, okay, so I downloaded this somewhere. Now I'm getting distracted. What do I have to do next to run cargo stuff? I have the file there. I need a lib file. Let's see, what do I have? ls source/source. We don't need that bin there. Main. We're going to make a lib file. lib.rs. I forget what goes in that, but we're going to stick it in here for now. lib.rs. And we need one more file. We need it from over here. The bundle RS. What did you mean to type with souring? Linux is good for souring. Free. I don't know. You must. I can't figure out the typo there. Yeah, Monte. It's going to be Monte Carlo. Now I have to copy all this stuff. Copy all this stuff again. So it's a bit of work to set up a project. You know. Bundle. Oh wait, I don't want to cdcp. That's why I just do dot. cp dot Butters of the Galaxy. What else do I have there I want to copy over? Not coding game main to dot. We had this issue with the way the libraries worked, and we're going to have to take the same basic structure here, and so again, the setup's going to be slow for these things now. We're going to try, if I have a way to reuse this. Part of this issue is we have this, and I forgot to file the guy for the bundler. There's an error in the bundler in the way it does the modules, that we have to have two different main points, one for local testing and one for online. But let's just run the cargo build now and see what happens. But at least get its stuff there. And we have the main file, and we have to start separating it around. We're going to have the exact same setup the whole time though, right? So if you actually look at, like, let's close all this stuff here, don't save. Tic-tac-toe, if you look at our coding game main, this was pretty much minimal anyway, right? Yeah, moderated steel, that actually makes a lot of sense. I'm wondering if I shouldn't do that right now. We have this whole thing set up and we've done nothing with it yet. Let's actually do that. Let's going to do copy source/bin main.rs to source entry.rs. Okay, because we have to copy, and then the main. What did I take for Butters of the Galaxy? So we'll set that up right now, because we're going to actually probably do enough of these. Bin. And this main is really, there's just a minor, actually I can say this something else, there's just a minor variation and workaround defect in the bundler. But this main is always going to be the same. Assuming we always create something called entry, and we'll always do entry there. And we can create the entry each time. So we don't really need an entry. So like the entry is just entry. And the mod is going to have to be, I forgot how to do the mods. Butters of the Galaxy source. We do pubmod. I'm going to copy some of these things as well. I'm going to copy these things as well because we reuse some of them, maybe. I'm going to give them a different name though. I should save this as it's. This is always the case that you end up with a bunch of stuff. So try is an optional try. This is the missing Rust feature. Return some. We're going to keep these names. Daza, I really suck at playing guitars. I did several albums with them, and for recording I can do it. For recording I can basically, you know, record and punch through the stuff, but I'm really not that good. I use them there because they have a better sound than synths, of course. And we want PubMod entry. And this is the minimal. We're going to have this in all of the games. And use import square leave, return some, and okay, I think this gives us our basic setup. Of course, now I have all this binary stuff here. Before I do git add dot get status. Commit initial setup. cp-r tic-tac-toe to skeleton. What do I have in the skeleton that's not supposed to be there? Nothing, I guess. Marcy, what's the link? Daza, I'm actually going to get back to doing music on my streams in the future. I intended doing it with Leaf. Well, it's my link. Oh, that's the... What are you showing me, moderated seal? This is, yeah, I remember this. Okay, but what did we do? I assume we win that thing. Gosh. So this was the Borders of the Galaxy, yeah. Okay, now let's go back to Tic-Tac-Toe. We're slowly setting up, very slow. So Dazzy, yeah, saying, I intended actually getting back to doing music. I want to get Leaf to the point where I can do some graphics, and my long-term goal there is maybe to create like a simulated analog synth and then get back to music. It'll be a fun thing for streaming, I think. But I have to get quite further in Leaf. I got the basic graphics, and I'll be doing more with that. Okay, so we have a skeleton, and we don't need this target in the skeleton. That's what's missing. Car. We don't need to car this. We don't need the cargo lock file either. That's their skeleton, and we don't need the single file, although probably we can leave it. Yeah, normal single file. Okay. Daza, Leaf is my programming language. It was part of the reason I'm doing Rust is to learn things about other programming languages. And right now in Leaf, it's working quite well. I put the SDL thing in, so I have an actual Leaf on the screen. I can probably quickly run and show that wherever this was. Source/Leaf algorithm stream SDL. Oh no, SDL. See my wonderful status here. If I go to the demo, so there's my Leaf program. It looks rather ugly right now because it's mainly importing SDL stuff. We'll put this back on top. I can't see anything. So /source/leaf/sdl/dis/leaf. So this is the local build of it, obviously, and we're going to compile this, and we're using the library SDL2 dot exe/temp/demo. Probably should put a dot over here. Probably works both ways. And /temp/demo. There we go. And this is how far I am in the SDL stuff. I have a Leaf that expands, and this is wonderfully, OpenGL accelerated. Not really relevant. And it also supports the close button. It's written in Leaf. I can show you roughly. It's not a very good example of Leaf because it's all basically importing stuff. So this is the main program. So like all of this stuff here is basically just importing SDL stuff. But it does work in Leaf, and so at the bottom here we have some actual Leaf, like the actual var I, var run, and while true. We have the event polling right here, and then we draw it and we move it around the screen. So this is Leaf, and it is the language I'm working on. This is not a great example of it, but the reason I'm doing the graphics is so that I can do streams with it that aren't really boring, because we want graphics in the stream, and so I have that, and I'll start doing them as I get, I'm probably far enough, but this one I'm going to do Rust for now. And the reason to doing Rust is because there's some features in Rust which are actually kind of nice, other features that aren't so nice, and we'll do it again. Alright, let's break this here, close this, and we're going to connect to a different file again. Uh-oh. We lost their default file. Got to get the order of this right. The order is important. So we're going to have to go find their default file again. What we connect to is the single file. And we might as well download the ID to it. Doesn't make a difference. Okay. Yeah, I need... Anybody know how to get the default code back? Is there a little... Well, that's going to screw up mine if I do that. Alright, let's do this. Let's disconnect. Let's restore the default code. Yes, default code, and we need to get this somewhere. We need to put that into our entry file. It was there. I did do it. Man, so I'm not that stupid. Somehow I did do it. Alright, so we can reconnect this here. Reconnect, use previously selected file, single file, upload file to IDE. And now that it's all there, it's going to complain, but we have to make an entry here. This doesn't have this stuff in it. This is now entry, and we have a function called entry. And that should be enough to actually get into the game and compile it. And as usual, we get it all set up. We're just gonna we're gonna go into tic-tac-toe, cargo build. Wow, this takes a long time. And I deleted parse input, so that was silly. I meant to delete print error, not parse input. And this has to be a public function. That should be good. That should let us... Okay, extern crate. Oh yeah, the botters is probably better. What do I call botters? What do they call botters in the previous one? Name tic-tac-toe. Okay. And what do I have to call the crate? Source bin. Where does the crate name come from? Daza, I do know C++. I know C++ well. Actually, Leaf is written in C++, so... Where does the name botters come from? What name do we need to change? Not that one. We have botters. Wow, this takes a really long time to set up to do this way. Name botters. I don't know where that name comes from. I don't know what hooking is, though. I don't know what DX9 hooking is. All my GL stuff's been mainly done on mobile and older desktops. How does a crate get its name? There's nothing called botters here. Is it really just from the TOML file? Yeah, it does. I'm actually going to get there with my Leaf examples eventually as well, because that's what I've been doing at the company Fuse. Is I've been doing the UI engine, so all the layout and stuff, and that's all done in GL. So I do know how I can layer it that way, and I know how to do that. And so I'll just be slowly working through that. Okay, so we're going to call it tic-tac-toe, I guess. Where are we? Tic-tac-toe. And the bundler is going to keep a thing called tic-tac-toe. Tic-tac-toe. So our skeleton isn't perfect. And source bin main tic-tac-toe. Tic-tac-toe. And cargo is, this should probably be underscores because I don't think it can support dashes. And does that actually get us somewhere? Alright, so we should have pub entry. We have pub entry now, so it actually works. So we have this working here now. Let's play the code, see what happens. I play 0, 0. The game's going to break, but I just want to see that it compiles, and we've got it all hooked up correctly. Yeah, invalid input. Eliminated! We did something wrong! No problem. Patch up name. Okay. Now, RLS is connected to the wrong project, so let's open a folder. Tic-tac-toe. Good. What does that do again? Gets RLS working. Hope RLS is doing something. Alright, we don't really want the side thing there, but we got RLS working at least. The Explorer, maybe I'll just enjoy takeaway. What are you eating? Don't leave us in mystery. What kind of food is it? We'll just make this wider so I can leave this here open. I'm going to zoom this in again. So now we have to start creating the basic game. So now after all this setup, half an hour, that's not a big... Umars. What is Umars? Umar's food. Okay, and so this whole setup was so that we can do a cargo build here. So we have a full Rust project here, and we have it structured in a way that we can bundle it into a single file for the coding game. And oh, English takeaway is wonderful. This is Daz. I'm talking about Daz's eating food. Make sure you dip your fries in vinegar. Vinegar for the fries. It's very important. If you want the authentic experience, you need vinegar and fries. So I get this all set up, and it's important this way because we can actually do testing in Rust, and we can do the benchmark, and we can set it all up so it's a real project. It's not just a simple not a simple one file. It's a real project now. We have that all set up. English takeaway is fish and chips. What else are you going to eat? Deep fried onions. Mmm. Or a big steak. Pizza. Why don't we qualify pizza as English? Alright, if we focus. Now, where do we want to start in this? Because we're going to have a lot to set up. And we're going to start at the logical point at the entry point here. And we have to decide what is the game state of the board. So we need something that maintains the state. And I'm going to separate these into files as they get too big, because if we do it right away, we overstructure the code. And so we're going to have the struct state. And we want a very compact way to represent the state. We're going to oversimplify. We're going to do something you normally shouldn't do. We're going to prematurely optimize this because we absolutely know we're going to need a super compact way to store the state. So if you think of tic-tac-toe, you have a board like this, and we'll do a miniature state right now. When you have a board like this, there's 9 spaces, and there could be an X or an O or nothing in each of them. So the most compact way you can do this is let's use a bit structure for this, and we have 9, so we're going to use an I32. So we're going to do it this way. We're going to do board X. And actually, we're going to do it as an array right away. I'm trying to think should we do it as an array or actually not as an array? Which makes more sense. We should do a board. And this is going to be a vector of I16 2. So what do you mean? I know it's going to go into the 9 by 9 board. I want to represent just the one 3 by 3 right now, and I know I'm going to have to make that sort of layered into multiple boards. There's not going to be multiple players. I assume it's just going to be the normal tic-tac-toe. I'm just starting with the original one here, and this one's going to be duplicated. Eventually, we're going to have a 3 by 5 grid of these things, but let's represent one individual board first, one 3 by 3 board, and we know we have to layer this. And so I took an I16 because this covers positions 0 to 9, 0 to 1, so it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. And we have 2 players in it, and what this board does is going to use a bit set. The positions that player 1 has will be on the first array entry, and the bits the second player have will be in the second entry. We could also do higher or lower order bits, but I think in this case we're just going to store 2 sort of bit layers of what's on the board. If neither bit layer is there, then it has those items. And we could test this locally. Actually, let's start testing this locally. Let's just start building this test locally right away, because this will be interesting. We actually really want this stuff to work locally before I even start playing with it that way. State rs, save this. librs, let's open that up, and pubmod. I have no idea what it's complaining about there. Oh, it's unused. Oh, that's fine. And so we want 2 basic options here. So let's set up the board. We have basic. I want a basic function. Let's have an option print the board, and we'll do this to the console print and self. And this won't return anything. And then we'll see how this board works this way. And we're going to run test functions that actually print this. I hope there's a default here. So what was that syntax again? No, not derive, clone, copy, default. And the defaults of I16s are 0, so that should be fine. And it has a default, so we're perfectly fine with that. And print, so the print board, we know it's a 3 by 3. So we're going to have 2 loops for y in 0 dot dot 3, for x in 0 dot dot 3. Derive. The word is derive, not drive. Derive. Derive, like deriving a class type. Okay, 0 to 3, and we have to put a line. We're going to draw the border correctly if y is less than... Let's do it this way. If y is greater than 0, for I... Is there a repeat function? I want to repeat something. Let's figure out how to repeat something in a print line. Got to repeat. Let's open up ZealDocs and see if it comes up with something. No, I don't want to download it. Repeat. Rust iter repeat. What does that do? How do I do this? Iter repeat. Dasa, it's not a bad assumption. I make typos all the time. Alright, so we have iter repeat. Okay, so standard iter. Or just use standard iter. And we want to do iter repeat. These are just the dashes for the board. We're going to rely on monospaced here, even though I hate monospace, but okay. If x is greater than 0, we're going to output the minimum line, print that to separate them. I don't know how wise it's going to be hard to read the board, but that's okay. And now here's the first spot we have to say, well, what position is at the board? and we have a linear position. And let's make a simple function right now that actually gets out the position at that point. Get player at position, get player at x. I'm going to say I32, and there's good reason to do this because that's the default type. It does. I make more errors in the stream live, and I notice, but I'm helpful to notice. And usually when I code, when I make an error, I usually just keep typing and come back to it, and I sort of register and come back to it, so it's weird. All right, so now we need bit masking. You know, we've never done any types of bits at all in Rust. So let bit equal y times 3 plus x. And does it have shifting operators? Let's just assume there's C-like shifting operators. So now we say player at if. So this needs a self on it. And self. If self.board 0 and bit equals bit. We don't even need the equals bit part there. This is probably fine. And bit. Although I don't know what Rust is going to tell us. Okay, that's a bit excessive to us at 200. We're going to return 1 here, player 1. And this function is mainly going to be used for debugging. It's not actually going to be used in the game very much. Actually, this better just be 0. 1 bit equals bit. Return 1. I know it could be put in the loop, but let's return -1. Or just -1 in Rustian terms. We could probably clean that up. So now we're going to do a match self.getPlayer at x comma y. Case -1. What are we going to print? We're actually going to put this all in. No, we're just going to do it directly. Yeah, let's do it this way. Print. Player 1 just becomes a space, or 0. Case 0 becomes a x. Case 1 becomes an O. And then we print line just to finish it off. Not here though. Here. And then here is going to be like, what's going on? There's something wrong, broken. But I guess that's supposed to be a panic. Now we should be able to compile all this, and nothing's going to happen. There's no cases in Rust. What am I doing? So we have this plugin which is supposed to be showing us the errors and the problems, but for whatever reason, the RLS plugin just doesn't like us. It never has. It never will. Okay, what do I have? So we're going to use cargo check. Clear and cargo check build. I guess we can just do check as well. Iter cannot be repeated with, okay, I guess we have to do a collect. Collect to a string, I guess. Something like that. No field board on type self. Well, that's unusual. It's right there. Maybe it just got screwed up by the previous error. Aha, that's why. I don't know what's complaining about now. Got something closed incorrectly. Closes that. That closes. Aha, that closes that. Okay, what's the error? Expecting token, comma. Why? Why is it expecting a token of comma? What is Rust? What is Zeal saying about repeat? Now I'm confused. Why is it expecting a comma? Comma, comma. Or is it like this? Alright, so it built, and I have nothing to, I have, Whether should sell, yeah, we need to do a take or something. You're absolutely correct. We want to repeat it 5 times. That's an infinite repeat now, isn't it? Take 5. Right. Now I'm going to build a test case. How does it do that again? Use state star. How do you mark test cases again? Let me look into Great Waters of the Galaxy tests. Config test, mod tests. We'll just copy a whole bunch of this stuff, okay? Extern create tic-tac-toe. Use state, we don't need that, but we'll leave it there. Configure tests, use tic-tac-toe state star. So we're setting up test correctly now. We want to see if it prints out an actual board. Tests. Maybe I should put this as part of the skeleton. What exactly did I save this as? No, 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 no. Not as untitled. Tests. State RS, there we go. Or should it be called state test? I don't know. State test probably would have made more sense because then I don't have the same name over here, the same short name, but I can use the structure here. Okay, so state test is going to do a print. I don't really need to print, we're just going to do this. I'm going to do an s.print, I think is what I called it, that, yeah. Cargo test. Uh-oh. State, state, state. We have something called state. Oh, it has to be pub. Yeah. Doesn't know what that is. Let's do clear. Can't figure what that is. Pub not needed here. Yeah, yeah, that's the weird stuff. Pub. Have to pub everything here. What's it complaining about, though? What's the error? Where did I do that? Test state. State. Use tic-tac-toe. I already did that. Don't use it there. Why is it giving so much output? Alright. How do I see the output? Why is it running so many tests? Why does it have so much output as well? Oh, because of that. How do I see the output from a test? Rust, see test output. See test output. I can look for that. There's no log files, but we can get rid of this untitled thing. Where's my test outputs? Well, let's just run help. Cargo help, or cargo tests help. It's too long, too. No capture. Okay, cargo test, no capture. That sounds good. Can I choose a directory? Cargo test dash no capture. It's kind of unfriendly to type that much, but okay. Unrecognized no capture. What did it say? Oh, it's like that. Alright, so I printed something wrong, but we have an empty board that almost looks correct. Print line, I didn't have anything here. So we have an empty board there, that's good. And I just wanted to see, so we have the empty board, that's because we're going to set stuff on that board now. Daza, yeah, everything's LED lighting. Hi, Nightwear. We're working on the tic-tac-toe game. Right now we're just setting up some basic coding, or basic state and stuff. We're going to play super tic-tac-toe. Well, first we're playing basic tic-tac-toe. And again, I'm starting with the over-engineered solution because we know what we have to go to. And I want to set up the local test cases. And so right now we're just showing that we can print out the current state. And our state's stored in little bit sets. And so we can do set player at as well. Dazavit, I'm surprised that it's the camera flickering from the LED lights, because the LED lights don't flicker. They produce a constant light. It's just like a direct energy current going. They're producing a constant light. There's no like timers in them as far as I know, or they have timers of some kind. Plus there's 5 of them and thousands of little lights on them, so I don't know. LEDs make camera flicker. Well, that sucks. I'm going to have to find a camera that doesn't flicker with LED lights. I don't know why they make it flicker, but okay. And player, right? 32. 32. And this set player at, because I'm just testing now, it's not going to really do the right thing. I'm going to say if player equals 0, I'm going to say let bit. And we should probably make a macro for bit, but okay, we'll worry about that later. Once we repeat it the 3rd time, we'll make the camera. We'll make it a macro. So this is self.board 0 or equals bit. Actually, we can just do this. If we make player a use size, no, that won't work. Player equals 1. And we can make it clear as well. If player equals -1, self.board 0 and equals the inverse of bit. I hope that's using the right size. 1 and equals tilde bit. So this is all our bit setup, and I just want the bit setup stuff to work first before we actually start coding the game, because it needs to be perfect. And s.set player at, I think is what I called it. Set player at 0, 0, 0. That'll put the x up there. S.set player at 2, 2 would be the first player. S.set player at 1, 0 is 0. That should be fine. Let's see if this is printing correctly so far. course not, I have errors. Okay, so we need to do a bit complement. But LEDs don't have flickering. LEDs are a constant light emission. That's why I'm really surprised. I mean, LED lights, it's just a little light. It just has a constant power. The lights themselves don't flicker. Unless the bulbs have some sort of refresh rate, but I don't know. Maybe they do. Maybe they're not just like my normal LEDs I play with electronics. Maybe they flicker. I'll have to look that one up because I don't. But I'll have to find a camera that can get rid of it. Alright, so how do we do Rust bit complement? Rust bit complement. Bit flags, bit flags. Okay, I'll try that, Daz. I'll see you next time. I mean, I believe you it's causing the flicker. I just want to know very specifically why it's causing the flicker. Bit flags, no literals and operators. There must be bit complement in here somewhere. Oh, maybe it does mean not. Well, let's try not. Not would make sense. Oh man, I wish the RLS worked, because it's hard with sorting through this thing again. Set player at has no return. It's private, okay, pub. I just want to see that we have a board here. Come on. Oh yeah. I'll go look at that later. I'm going to open the link. Then we'll see why. I gotta look at that later. Okay? I gotta keep working on the code right now. What S? Okay, so this looks about correct. So we have the board here, and that's what I wanted to verify. We have... I want to do a clearing as well, just to make sure that works. Set player at... Let's say 1,2 is 0, and then S set player at... So it shouldn't change the output. I want to clear it as well, make sure clearing is working. And I just want to do this to make sure... Okay, just read what it does. It says, this causes the light to be less bright over time by pulsing the LED. If the pulse happens rapidly enough, they are undetectable to human eye. Nonetheless, well, why is it trying to reduce the brightness? Why don't they just let the LED go to the full brightness, and then I can have brighter lights? Instead of having 5 of them up with a whole bunch of LEDs, just put the one LED brighter. It makes more sense. Okay, so if I set and clear something, I should get the same output. That's what I'm checking, because I've never used the bit operators before in Rust. I want to make sure they work. Okay, I got them. That's working correctly. So we have a state. We have a state that represents this. Because I like Kaboom. Now the next thing we have to do in state, we have to determine if somebody's won the board. That'll be the next most important thing. We're going to say, has somebody won this board? And I'm going to do that. Again, I'm going to avoid options and stuff. I'm just going to put directly the bitmaps. Function get winner and self. It's going to read I32. It's going to return -1 if there's no winner. We can use a result. An option I32. I'm not sure if referring to the players this way is going to work, but it's not going to make a difference. The default size. Okay, so thanks, Daz. We solved the mystery why the camera flickers, and now I just have to look for a camera that doesn't flicker. If I can buy new equipment at some point. Okay, so now we're going to scan the board for winners. And there's only a certain number of patterns that can win a game, and we're just going to look for those patterns. there's only, if you look at the game, there's only 1, 2, 3, 4, 5, 6, 7, 8. 8 ways that a game can be won. And one way that it can be finished, a tie. And actually, so this is going to be more like an enum, a result. It's going to be more of a game state. We're going to have an enum up here, enum game state. And it's also allowed to have a derive, clone, and copy. It's going to have a default as well. Implement default for game state. Function default self. And the game is still open. That'll be the default, of course, because that makes the most sense. Self open. And it's going to be win 0, win 1, and tie. We're not actually tie, we're going to say closed. Just when nobody, there's no more moves. There's no more moves to make, there's no winners, it's win 0, win 1. Technically it's a tie, but we'll just call it closed because it's opposite hyphen. Yeah, Daza, that's a good solution. Let's just rewire the house. Okay, so the game state, and so now we want to find get state, public function. Wow, calling something state on a state class is kind of interesting. I don't know what else it's called. Get. If I'm trying to interest in the current state on the state class, what's another name for this? Let's say game result, just to be clear, to have a different name, game result. RFC, I was thinking about that, but I actually don't think I need to ever check to see if a given player wins. I think I actually just need to check, well, except for testing, I just need to check who wins or not, or if there's a state, who's winning. And so it's not, I'm never going to be calling get state, say, did player 1 win? I'm just going to say get state, and then check the results. Oh, I see what you mean up here. Win I-32. Does that make my enum much bigger? That's going to balloon my enum, isn't it? But in this case, does it matter? No, I don't think that's going to make it matter. So let's do it that way. Daza, I live in Germany. Win I-32. Okay, so now we have to. Anybody know how to encode binary numbers in Rust? Rust, encode binary number. Can I do binary literals? This would be great. Doesn't know I'm not Germany. I'm not German, I just live in Germany. Binary. I'm looking for a way, because I want to just encode the winning states. I want to say, like, let win states equal, and then do some sort of binary encoding where I can just literally do the game state of, like, because we know we have 3 sets of 3, and we can encode them, so like 1, 1, 1 would be a win. And I just want to encode these all this way. I just need to know how to do that in Rust, if there is a way to do it. Yeah, Daz, I'll look for another webcam. I'm trying to keep my costs for the show low down. If you guys want me to get more equipment, I can also, you can run over to my Patreon page and support me, or subscribe in Twitch, and this really helps me out, and I slowly buy new equipment. I bought a new keyboard. Hopefully it's a bit quieter, and I gotta find a way to make it even quieter. Is there a way to do binary literals in Rust? What's the easiest way to generate all these numbers then? If I can't do binary numbers, I really want to do this. Well, let's just list them first, and then let's figure out what the win states are. We might just manually convert them over. Does I'm from Canada originally. So let's just list all the states where you can win, and then we'll convert them to the actual values. In Leaf, my programming language, you could actually do this directly. You can actually encode binary literals for exactly these types of purposes while using binary maps. Maybe Rust can do it, I just can't find the syntax for it right now. So these are the 3 horizontal ways you can win, and now we have to do the 3 vertical ways. Daza, I do speak German, yes. So we have 3 vertical ways you can win as well. So these are our bitmaps that line up with our I16 up here. And so these have to be I16 values. And now we have the horizontal ways that we can win. And there's 2 of those. Nein, danke. Kein Deutsch heute. Is this correct? There's 8 ways you can win in tic-tac-toe. I'm encoding these. Now, lacking a way to encode these directly, let's just figure out... this is going to be painful. I don't really want to do this way, but I don't have a choice. So, 0, 0, 1, 1, 1. In decimal is 7. 7. This is like so error prone here, yeah? Somebody can please double check this stuff. Back to binary, 1, 1, 1, 0, 0, 0. In decimal is 56. Back to binary, 1, 1, 1, 0, 0, 0, 0, 0, 0. In decimal is 448. Now we have the next weird one. We have in binary, we have 1, 0, 0, 1, 0, 0, 1. In decimal, that is 73. And again, this is being over-optimized right now because I know... So I don't know if that really helps me because I still can't convert those in my head very well. Although, yeah, I have 3 sets of 3. Octal. Probably not. Rust. Octal literal. Hey, there is binary. Well, what do you know? There you go. Perfect. I didn't know there was binary. There is binary. I probably can't do the underscores, though. Ah, it does. Wonderful. So that's actually correct. But these all have to be I16. These should probably all be U16 because they're binary. And this should be U16. It's perfect, because this is exactly the way I'd notice in Leaf, other than U16. And I love the ability to do this, I mean, because for exactly situations like this, we have it a lot clearer. Does this actually have to be attached, or can I do it like this? Okay, so those are the win states, and U16, that should be all fine. Bit, or equals bit equals 1. Is there another I16 here somewhere? No. So these are the win states. And this is a... It's a fixed vector. And the way we check this is if we check these states against both of the players. And I don't think this is a correct way to do the win states, but we can basically say for I in win states, let's hope this works somehow. If self.board 0 and I equals I, then we return game result win 0. Thanks. Thanks, RFC. This is at least clear enough. I can probably put one there too. It's at least clear enough to debug that we have the states where we can win. We can do it for 2 as well. If the second border was, then they win 1 instead. And now we have one final state. If self.board 0, this is the game where, and yeah, see, I got that. I put that in quickly. You got it. Or self.board 1 equals 0b 111111111 016. Return game result open. I closed. That should be closed, not closed. Otherwise, we return game result open. Now, this should actually be done first because it's really fast. And it's actually probably going to come up often enough, but we can do that later. Worry about that later. So, what win state does is it checks the state of the board. Does I just said no German today. And now we have errors. Variant open found here. We need variant closed. Variant not found in state game result open. Self open. That should have worked, no? It does contradict itself, Daza. Close is okay. We gotta get rid of this unused stuff. Why is it compiling everything twice? Why is it compiling this stuff twice? This is really weird. If anybody can explain this, Cargo is now compiling my files twice. This is weird. Can I give like a directory, like tests, cargo tests? No. Apparently not. I'd like to give a directory to test. Whatever, do this. Pattern matching. Can't leak private type. Pub. Okay, so that compiles. Now we actually want to do. Gee, we should probably test this. Test it a little bit and win. Let mut s equals state. I don't know how exhaustive we have to be in the testing here, and set player at, let's say 0, 0, 0. Let's just set a whole bunch of common ones here. And I think we have an assert. I forgot what assert looks like. Assert. assert equals or something. Assert, rust assert. Assert equals, wonderful. Assert equals. Game result open s dot. What did I call the function now? Get state. Let's see if that's so far. That should give us a closed state. Wow. What's it whining about now? Oh, you can't test it unless you can print it out? That's weird. Well, we can just derive it from that if we want. We just say debug. I still don't know why it's compiling twice, but... Oh, yeah. Partial equality. Alright, so win works. Moderate seal to fill the board. Well, we are setting the board. You mean just to fill it with random values or what? So we can do set player 1 and 2, and this should now be assert game result is win 1, win 0, first player 1. Okay, now I actually made a mistake over here. When I said we should check this first, this is wrong because you might have a win first. So we have to get that closed result too. We have to test that at least. And what's an easy way to test this? Daza, be nice in the chat. Well, we could do this. We could make a function, public function set player entirely, anmu itself, and yeah, I was just about to write that function moderated seal. That's exactly what I'm writing now. So S is a U16, player is a I32. I just make this a U size now because it's only used for testing. Set plays. Set plays is actually probably a cleaner word. And self.board player equals S. So this sets the entire play state, which is good. And we can do another one, wins. Let mut S equals state default. S.set plays, and actually I should put the order in there. The order, the player first, because it's going to look cleaner for the test case. That's the only reason. Set plays 0 0 B, and let's just assume all the 0 0 first. U16, and we need a board where neither person wins, which is a reasonable board, and this is 1. And which board do they neither win? He can have those two. He can even have those two. And then have this one. And that's no wins then for him. And this should give us a closed state. Close. Closed, probably better. Alright, so that works. So I think our state works well enough. I think we have the game encoded, tic-tac-toe encoded in a bit noise level in Rust. RFC, I thought about that a lot as well. And I think that's going to complicate it more to try and encode the player winning on both ones. Because we have the same, like, we're just checking the same states and the shifting. So this is going to cost the same whether we shift it or not. And for checking the full state of the board, I think it's easier if we keep them separated, because we could do this. And I was thinking forward is that this is going to make it easier to determine where we can play, because in the two-bit approach per board space, it's harder to figure out where we can play. But if I have one board state, I can do this. I can order the two boards together. Now I have all the spaces in the board that are filled, and I can just look for the 0, and I can figure out where to play next. And so that's why I did it this way. I think it's going to be more effective to do the 2 arrays of 1 bits rather than an array of 2 bits for each spot. Alright, so that should be enough that we can actually go to the entry and get this working. So let's just do the basic one first. Let mut state equals state default. This is a new game. And this is where the last player played. If row... And actually, whose player is what? Do we know which player it is? We don't need this. We don't care about this. We don't care about valid actions. We're assuming the game is reasonable. So we're just going to read this in and discard them. And it doesn't matter. This doesn't matter. The speed thing doesn't matter here. So we read the line and opponent row and column. Now we have to figure out so I guess this is how we figure out whether the first or second player. I'm going to have to track this as well. Who's the first and second player? Actually, we can always assume we're the first player because it's going to make no difference, I think. But maybe we should line it up with the game, so in case we have to debug, though. So -1 means first turn means we're player 0. Alright, so if opponent row equals -1, else this, and we're going to do the state dot player equals 1, or state dot player equals 0. This is going to be a use size. And the state encodes who is the current state. We probably don't want to put it here right away, though. Use size. And because this is the part that's going to duplicate down, and we don't actually need to duplicate this, so there's going to be a meta state and a clone state, but for now we won't have to worry about that. So we have this size here. So if it isn't -1, though, we're going to have to say state. I'm just really wondering, though, would it make sense for efficiency and simplifying our formula everywhere else to just assume that we're player 0? And, well, let's just encode it for now. Because then we also have... No, I meant player. And alt player then is also a use size. Alt player. And I have a strange feeling that this is going to end up actually just making us... Yeah. I'm already not liking this. If we do have fixed, it's better to take us as always the first player, but I don't know if that affects strategy or not. Maybe we should encode first player or something, but let's just get the board first of all. And let's do state that alt player state dot what do I want to do? So if there's not -1, then we have to do state dot set set player at. Player at opponent column, opponent row, we have to track whose turn it is. Current turn, it's a use size. Current turn equals 0. Else current turn equals 1 use size than 0 use size, else 1 use size. So this alternates between the turns. I think we have to track this on our own. Yeah. The wait. Actually, can we know that? Okay, yeah, no, we don't need to know their turn. We don't need to know anything. They're... So I'm getting this all screwed up now. I'm getting really screwed up here. And Daz, I've been streaming since the late last fall. We don't need this player and stuff. We're just going to assume that we're always... Man, I'm getting it screwed up already. We need to say first turn equals true. And we have to do this if first turn. Oh, this stream I've been on since I think 7 or 6:37. I don't know anymore. Opponent row equals -1. Then we say state dot. This is where we have this. This is where we have this. We don't need to track current turn, state player, else. I think we have to track our own state. Now, if the opponent didn't have the 0, and let me change this all to the proper tabs. City spaces. And then we have to set their state. Then we set their state, opponent row column, state dot alt player. Probably opposing player. Okay, and that sets the board for them. So at least we have this. So we can actually print the state of the board after each line. And we have to figure out what we do. Our move, we're going to figure out what our move is. Let's just create a function that gets the next free move, and let's go with that first of all. Next free and self. And this returns a tuple of for I in 0.9 use size, use 16. Actually, it doesn't make a difference. Okay, board equals let full equals self.board 0 self.board 1. This is all of the states. If full and I or 1 I equals 0, then we're going to return that state. Otherwise, we're going to panic down here. Oops. Board full. We're not going to return an option. We're going to say we assume we can't call this if it's already full. They should have checked that before. And this is only mainly for testing right now anyway. So we're going to return, this is going to be a tuple of I mod 3 I divided by 3, and that'll give the position on the board. And we're just going to set, for the initial test, we're just going to emit the next position. Let nx and y equal state dot next position, next free. Then we do state dot set player at nx and y state dot player, and we're going to emit this value as well. Nx, and y, and we can probably give it a print line of the state saying what is our current state, and we're actually going to do a dump on it, state.print, and we'll make print go out for convenience sakes. Print will just use eprint instead, eprint line, eprint. This we use this for debugging in the game then. And now we have, now we should at least, oh, now RLS is finally picking up errors. Wow, look at that. Use state star. Now it doesn't have it. Clear and cargo build. Oh wow, now we have different errors. Did you mean opponent row? I suppose so. Don't need so many P's. How do I take so many P's every single time? Oh, forgot to make these things public. Just gonna make them all public because they're gonna be important later for the testing or for the running. So now RLS is not helping us again for some reason. Let me just say as I32. Turn. As I32. Oh, we already get into the boring problem. This is actually an error somebody mentioned to me. That this should work. There's just an error in the borrow checker now that doesn't let it work. That is somehow evaluating the order wrong of the parameters. Let our player, or it's OP, yeah. Current player or something, I don't know. Okay, that should be enough to actually play the game. Interestingly, we'll probably lose because I'm just taking the next. Well, actually, unless he does, if he has no strategy, we might actually win. And yeah, so they win, of course. That's, I mean, because we're not checking anything right now. We have some kind of representational error here. Okay, so we have a mismatch somehow between you're clicking on it and keep typing ads. It's just there to distract you. So we have a different game state than they have. And this is a problem. So what clearly do they expect? They're giving us row and column, and they want row and column. Let's check that very carefully, because my state, I do x comma y. I hate things that do row comma column because XY is more natural. So we probably have that wrong. Opponent row, opponent row, opponent column, opponent row, that's correct. And this should be ny, comma nx. Okay, so we won, and what the hell? X. We have an X. We're sticking the wrong values in there. Oh, I know why. I know what we screwed up. First turn equals false. We keep alternating the state of the players. I just want to make sure we have the actual players in the right state. So the boards should line up, otherwise we'll have issues. So we're doing double checking that the boards line up. Good, so the boards now line up. And let's see how far we get if we submit this. The game works. Often in Wood Leagues, just having a game working is enough to get somewhere. And so it wins in several of them, so it might be okay. We don't know for sure. Let's look at the leaderboard. Where are we? Go around me. No games reporting. Well, this one should go. I was hoping this would go faster than Botters because the game to evaluate should be super fast. Although, once you get to the higher leagues, I imagine that if you start doing your look ahead, it's basically always going to take the 50 millisecond time allotment because why would you take less? I wonder if this is enough to get past this league. Usually it's been so far. Like I said, usually so far Wood League has just simply been if you can play the game and not make an error, you win. Maybe they had to go a little bit harder this time, so we might have to do one phase look ahead first of all. Which wouldn't be so bad. It looks like we're actually going to have to evaluate the states. Let me let that run and I'll be right back. Okay, so that got us far enough. So I guess the boss did something random, and we get to Bronze League just by playing the game. And this sets up the real game now. This sets up like the full game. How do I... So the full game is going to be different. We're going to actually have to calculate what games, and the input tells you what moves are available, but I think these are the standard Ultra Tic-Tac-Toe rules, that when you play on the sub-board, a small one, then you have to play on the big board in the right place. When a player plays on a small board, he also decides where the next player will be allowed to play. For example, if a player has played in the bottom left square in one of the small boards, the next player will play in the small board located at the bottom left square of the main board. If a player is sent to a board that is either 1 or full, then that player is allowed to play in an empty square. Any empty square. Okay. I never knew this condition. The person who wins the more smaller ones then wins the main board. Okay, so now this is where we set up the layering. I'm feeling a bit tired today, though, so I think I'm going to start with this tomorrow. I got the basic game here working, and I think I'm going to go work on this tomorrow again, because I'm not feeling in the right headspace to actually continue this right now. But this sets up the basic game, and for Oilers to Sal's thing, yeah, we're basically in the code. We're going to duplicate this state. This state now becomes a set of 3 by 3 of this state, and it's also going to be a vector, so the full board is going to be a bit smaller, and we have to restructure that down to have it. Then we're just going to, I assume, maybe this Bronze League, simply playing the game again, maybe we win, I don't know. We'll have to see, just as long as we encode the game and get the next move, and then we'll trace that, and then we'll do that tomorrow. We'll set up that state tomorrow. Yeah, it does. I'm not in the correct mindset for this right now. So we'll set this up to tomorrow. We'll go through and we'll convert this to the full game, and then we'll play that, and we'll see just playing the full game and see if we can get started on the actual look-ahead logic and Monte Carlo sampling. And but thanks for watching, and I think we got basic progress here. We have the basic game working, which is always good, and the setup took a bit longer than I wanted, of setting up the terminal and stuff, and there's some weird double compilation going on here too, which kind of bugs me, but I think we have everything here, and that'll get us in good state for tomorrow. Git add source, add tests, git status, git commit, past Wood League. So for tomorrow, we can actually do the actual bit of logic, get the full game, at least get the full game going tomorrow, and then set it up for the Monte Carlo sampling. Maybe tomorrow I'll do live stream, I'm not sure. I have to do a mentoring session at around 4. Right in the middle of the day, it's booked. It's always weird like that. They book them right at very inconvenient times. Nobody wants to get up early in the morning, I guess. Okay, so thanks for watching. We didn't go very long today, but that's okay. We'll catch you tomorrow. We'll keep going tomorrow in the evening. Thank you.